Rocking M Studios presents a Meads Steel Education production. From the Second Life University of Patton Bay at Midnight Springs, Washington. Real life learning in Second Life. We bring you Wild World of Science. Chapter 13-1. Earth's Oceans. Video read along. With course instructor, Mr. Ronald Jowsey.
Greetings, my fine young scientists, and welcome back. Today we will continue our introductory look into Earth's oceans by completing our Chapter 13-1, Earth's Oceans reading assignment. As always, press pause or rewind the video as needed during your learning. Now let's get started, shall we? Chapter 13-1, Earth's Oceans. Directions. Read Chapter 13-1, Earth's Oceans. Highlight important information and vocabulary. Use the information from the reading, and use complete sentences to answer the questions given. After you read this section, you should be able to answer these questions. What affects the salinity of ocean water? What affects the temperature of ocean water? And how does the ocean affect air temperatures? What is the global ocean? Earth has more liquid water on its surface than any other planet in the solar system. In fact, 71% of Earth's surface is covered by liquid water. Most of Earth's water is found in its oceans. There are 5 main oceans on Earth. However, the oceans are all connected to each other. Therefore, scientists often refer to all the oceans on Earth as the global ocean. The continents divide the global ocean into the 5 main oceans. The largest ocean is the Pacific Ocean. The Atlantic Ocean is the second largest ocean. It has half the volume of the Pacific Ocean. The Indian Ocean is the third largest ocean. The Southern Ocean extends from the coast of Antarctica to 60 degrees south latitude. The Arctic Ocean is the smallest ocean. Much of its surface is covered by ice. The figure to the right shows where these oceans are found. Question 1. Describe. What divides the global ocean into 5 parts? Earth's continents divide the global ocean into the 5 main oceans. Question 2. Identify. What are the 5 main oceans? The 5 main oceans are the Pacific Ocean, the largest, the Atlantic Ocean, the second largest, the Indian Ocean, the third largest, the Southern Ocean, and the Arctic Ocean, which is the smallest ocean. How did the oceans form? Soon after the Earth formed, it was very different than it is today. There were no oceans. Volcanoes produced large amounts of ash, dust, and gases, including water vapor. These gases began to form the atmosphere. Slowly, Earth cooled. By about 4 billion years ago, the temperature was low enough for the water vapor in the atmosphere to condense. The liquid water fell as rain. The rain filled the basins in Earth's surface, and the first oceans formed. Looking at the diagram in your reading, we can see that plate tectonics has caused the shapes and locations of Earth's oceans to change over time. About 245 million years ago, the continents were joined into one large landmass. The oceans were one body of water. By about 180 million years ago, the continents had started to break apart. The North Atlantic Ocean and the Indian Ocean began to form. By about 65 million years ago, most of the Atlantic Ocean had formed. However, the South Atlantic Ocean was much narrower than it is today. Today, the continents are still moving slowly, about 1 to 10 centimeters per year. The Pacific Ocean is getting smaller. However, many of the other oceans are growing. Question 3. Identify. Where did some of the gases that formed Earth's atmosphere come from? Volcanoes produced large amounts of ash, dust, and gases, including water vapor. these gases began to form the atmosphere. Question 4. Explain. Why have the shapes and locations of the oceans changed with time? The shapes and locations of the oceans have changed over time due to plate tectonics, which is still moving Earth's continents. Why is ocean water salty? Ocean water is different from the water that we drink. People cannot use ocean water for drinking because it is salty. Most of the salt in the ocean is the same kind of salt we use on our food. This type of salt is called sodium chloride. It is a compound made from the element sodium, Na, and chlorine, Cl. Ocean water also contains other dissolved solids, including magnesium and calcium. These dissolved solids make the water taste salty. The graph shown in your reading indicates the amounts of different kinds of solids in ocean water. As rivers and streams flow toward the ocean, they dissolve minerals from rocks and soil. These minerals include halite, sodium chloride, and calcite, calcium carbonate. The rivers carry the dissolved minerals to the ocean. At the same time, liquid water in the oceans evaporates to form water vapor. As the water evaporates, it leaves behind the minerals that were dissolved in it. Question 5. Read a graph. Which two elements make up most of the dissolved solids in seawater? Looking at the graph, we can see that chlorine, 55%, and sodium, 30.6%, are the two elements that make up most of the dissolved solids in seawater. Question 6. Where does most of the salt in the ocean come from? Most of the salt in the ocean comes from rivers and streams that dissolve minerals from rocks and soil and carry them to the ocean. What is salinity? Salinity is a measure of the amount of solid material that is dissolved in a certain amount of liquid. It is usually measured as grams of dissolved solids per kilogram. On average, ocean water has 35 grams per kilogram of dissolved solids in it. This means that 1 kilogram of ocean water has about 35 grams of solids dissolved in it. If you evaporated 1 kilogram of ocean water, 35 grams of solids would remain. Effects of location on salinity. Some parts of the ocean are saltier than others. Most oceans in hot, dry climates have high salinities. In these areas, the hot weather causes water to evaporate quickly, and salt is left behind. For example, the Red Sea in the Middle East is very salty. The climate there is very hot and dry. Some parts of the ocean are less salty than others. Along the coastlines, fresh water from streams and rivers runs into the ocean. As fresh water mixes with ocean water, the salinity of the ocean water decreases. For example, the salinity of the ocean waters near the Amazon River is much lower than the salinity in other parts of the ocean. This figure shows the salinity of ocean water in different parts of the world. Question 7. Explain. Why do oceans in hot, dry climates tend to have high salinity? Most oceans in hot, dry climates have high salinities because hot weather causes water to evaporate quickly, and salt is left behind. Question 8. Infer. The Gulf of Mexico is located between Mexico and Florida. Why is the ocean water in the Gulf of Mexico less salty than in other places? The ocean water in the Gulf of Mexico is less salty than in other places because fresh water from the Mississippi River mixes with the ocean water, lowering salinity. Effects of water movement on salinity. The movement of water also affects salinity. Slow-moving ocean water tends to have higher salinity than fast-moving water. Parts of the ocean with slow-moving water, such as gulfs, bays, and seas, often have high salinities. Parts of the ocean without currents are likely to have higher salinities as well. Question 9. Describe. How does water movement affect salinity? Slow-moving ocean water tends to have higher salinity than fast-moving ocean water. What affects ocean temperatures? The temperature of ocean water decreases as depth increases. However, the temperature change is not uniform. Scientists can divide the water in the ocean into 3 layers based on how temperature changes. These 3 layers are the surface zone, the thermocline, and the deep zone. If we look at the graph in your chapter reading, we can see that the surface zone is the warm, top layer of water. It extends to about 300 meters below the surface. Convection currents mix the heated water with the cooler water below. The thermocline is the layer of water below the surface zone. It extends to between 700 meters and 1,000 meters below the surface. In the thermocline, temperature decreases quickly as depth increases. Deep zone. The deep zone is the deepest layer of the ocean. The temperature in the deep zone is only about 2 degrees Celsius. Question 10. Identify. How does warm water mix with cool water in the surface zone? Convection currents mix the warm water in the surface zone with the cooler water below. Surface zone. The surface zone is the top layer of ocean water. It is heated by energy from the sun. As the ocean water is heated, it becomes less dense and rises above denser, cooler water. Convection currents form as the water moves. These currents can move heat within the surface zone to a depth of 100 meters to 300 meters. Therefore, the water temperature within the surface zone is fairly uniform. Question 11. Predict consequences. What would happen to the water temperature in the surface zone if convection currents did not form there? Explain your answer. If convection currents did not occur in the surface zone, cooler water would not be mixed into the top warmer layer of the surface zone, and temperatures would continue to rise. Thermocline. The thermocline is the layer of the ocean just beneath the surface zone. Within the thermocline, the temperature of the water decreases a lot as depth increases. This is because the sun cannot heat the water below the surface zone. In addition, the warm water of the surface zone cannot mix easily with the water below. The depth of the thermocline is different in different places. It can extend from 100 meters to almost 1,000 meters below the surface of the ocean. Deep zone. The deep zone is the layer below the thermocline. In the deep zone, the temperature of the water is about 2 degrees Celsius. This very cold water is very dense. It moves slowly across the ocean floor and forms the deep ocean currents. Changes in surface temperature. The temperature of water at the surface of the ocean is different in different places. Surface water along the equator is warmer than at the poles. This is because more sunlight reaches the equator than the poles. Surface water at the equator can be up to 30 degrees Celsius. In the polar oceans, water at the surface can be as cold as 1.9 degrees Celsius. The temperature of water at the surface of the ocean can also change during different times of year. Many areas receive more sunlight in the summer than in the winter. In these areas, the surface water in the oceans is warmer in the summer. Question 12. Explain. Why is surface water warmer at the equator than at the poles? Surface water is warmer at the equator than at the poles because more sunlight reaches the equator than the poles. How does water move on Earth? Imagine that you could see Earth from outer space. You would see green and brown land masses, blue oceans, and white clouds. These parts are involved in the water cycle, which is shown right. Looking at the diagram in the chapter reading, we can see three of the processes involved in the cycling of water on Earth. Evaporation is the process by which liquid water changes into water vapor, which is a gas. Most evaporation happens when sunlight heats water on Earth's surface. The water vapor moves into the atmosphere. Condensation is the process by which water vapor changes from a gas to a liquid. Condensation happens when water vapor cools. Clouds form by this process. Precipitation is rain, snow, sleet, or hail that falls from clouds to Earth's surface. Most precipitation falls directly onto the oceans. The water cycle is the movement of water between the atmosphere, the ocean, and the land. The ocean is important to the water cycle because it holds nearly all of the Earth's water. Question 13. Define. What is the water cycle? The water cycle is the movement of water between the atmosphere, the ocean, and the land. Take a look. Question 14. Identify. Where does most precipitation fall? Most precipitation falls directly onto Earth's oceans. How do the oceans affect air temperatures? You may know that many living things depend on the oceans for food and shelter. However, the oceans also help to keep the rest of the planet suitable for living things. This is because the oceans absorb and hold energy from sunlight. This helps to keep temperatures in the atmosphere from changing too much. The ocean absorbs and releases heat much more slowly than the land does. Air can absorb heat from the oceans. Therefore, the oceans help to keep air temperature steady, as shown above. Starting at the top of the flowchart shown in your chapter reading, we can see that sunlight heats ocean water, air, and land during the day. Following the arrow on the left, we are reminded that the air and the land lose their heat quickly. The top arrow on the right reminds us that the ocean loses heat slowly. The air absorbs heat from the ocean during the night. This helps the air temperature stay steady. Question 15. Explain. How do the oceans affect air temperatures? The oceans absorb and hold energy from sunlight. Because the ocean absorbs and releases heat much more slowly than the land does, air can absorb heat from the oceans. Therefore, the oceans help to keep air temperature steady. If there were no oceans on Earth, the air temperature could vary from above 100 degrees Celsius to below 100 degrees Celsius in a single day. Such large temperature changes could cause a lot of severe weather. Life as we know it could not exist in these conditions. The ocean can also affect the climate of different areas. Remember that ocean water at the equator is warmer than ocean water at the poles. Currents in the ocean move the ocean water from place to place. This helps to distribute heat throughout the Earth. The warm water from the equator can flow past land at high latitudes. The air absorbs heat from the warm ocean water. As a result, the land can have milder temperatures than other areas at the same latitude. For example, the islands of the United Kingdom are at about the same latitude as parts of Canada. However, a warm ocean current flows past the United Kingdom. As a result, its climate is much warmer than much of Canada's. Question 16. Identify. What helps to distribute the heat in ocean water? Ocean currents move warmer water from the equator towards the poles and colder water near the poles towards the equator. This helps distribute heat throughout the Earth. This concludes your Chapter 13-1 video read-along. Be sure to turn in your assignment when you have answered each question. Until next time, be safe, make good choices, and I'll see you again soon.